So here we have a system of 3 equations and 3 variables. And in order to solve that, we are going to work on creating fewer and fewer variables. So the first thing we have to do is pick 2 equations and eliminate one of the variables. So I'm noticing that if I look at my first 2 equations, the coefficients for the y's are exact opposites. So that will be my easiest pair to work with to begin with. So I've got negative 2x plus 2y plus z equals 14. And my second equation is 3x minus 2y plus z equals negative 5. And because those y values are, the coefficients are exact opposites, here's my system that I'm looking at. Because these coefficients are exact opposites, if I add this value to this side of this equation and the negative 5 to the other side of this equation, the y's will be eliminated. So I'm going to go ahead and do that. Negative 2x plus 3x is 1x. 2y minus y, 2y, sorry, is eliminated. Z plus z is 2z. And 14 plus negative 5 is 9. So I've got one equation, 2 variables. I'm going to save that equation over here. I'll come back to it later. X plus 2z equals 9. Now I need to use this third equation somewhere. So I'm going to pick 2 more equations, it has to include the third one, and eliminate the y's again. If I eliminate another variable, then I still have 3 different variables instead of 2, so I'm going to stick with the y's and eliminate that. And I'm noticing when I look at it that the values for the coefficients for these 2 y's are at least opposites or opposite signs. So I won't have to change any signs anyway. So I'm going to use those. So I've got 3x minus 2y plus z equals negative 5. And negative x plus y minus 2z equals negative 8. This is the system that I'm looking at now. And what I'm going to do is try to eliminate those y's. I could solve for y here and then substitute, but I'm going to go ahead and instead of doing that, I'll multiply through by 2 in this bottom equation. Multiply this side of the equation by 2 and this side of the equation by 2, and that will create opposite coefficients here. So my new second equation will be, distribute the 2. 2 times negative x is negative 2x. 2 times y is positive 2y. 2 times negative 2z is negative 4z. And this side of the equation becomes negative 16. Now, my top equation stays the same. And if I add this expression to this side of the equation and this expression to the other side, then my y's will eliminate. So these two to go together. Negative 2x plus 3x is 1x. 2y minus 2y is 0. Negative 4z plus z is negative 3z equals negative 16, and negative 5 is negative 21. I've got another equation with only 2 variables. So I can use that. X minus 3z equals negative 21. So now I have 2 variables in a system of 2 equations, and I'm much more familiar with solving that. So I need to eliminate one of these 2 variables. I'm gonna go ahead and eliminate my x's because they're already the same coefficient. So I just have to multiply through by a negative to make them opposite coefficients. Now if I add, I get 0x's plus 5z equals 30. And that's an easy equation to solve. Divide both sides of the equation by 5. Z is equal to 6. So I am most of the way there. I already know what z is. Z is equal to 6. Now I can go back to one of these two equations that have just a z and an x in it. I'm going to use that top one. It's got smaller numbers in it, so I tend to like it better. X plus 2z equals 9. But now I know what z is. Z is 6. So I'm going to substitute a 6 into that value instead of z. Z is 6. So now I can go ahead and solve for x. X plus 12 equals 9. Subtract 12 from both sides of the equation. I am left with x is equal to negative 3. X is equal to negative 3. Now all that's left is to figure out what y is. These two equations don't have a y, so I have to go back to one of my original 3 and solve for y there. I like the blue one best personally because the y doesn't have, the coefficient of y is 1. So that tends to make it a little simpler. My equation is negative x plus y minus 2z equals negative 8. And I know what x and what z are. So I'm going to substitute x and z. X is negative 3 and z is 6. And simplify and solve for y. The opposite of negative 3 is positive 3 plus y. Negative 2 times 6 is negative 12. 3 and negative 12 is negative 9. Add 9 to both sides of the equation, and we get y is equal to 1. So x equals negative 3, y equals 1, z equals 6. If you were to solve these, if you were to substitute these three values into any and all of these equations, they should be true. And on your test, you really should go back and double check that when you substitute, that they work. At least you don't necessarily have to check all three, but if it works for 2 of the equations, it should work for all 3. Okay, I hope that helps.